We expect that it's going to have leading benchmarks on a bunch of the benchmarks.
The agent achieves new state of art of 27% on this benchmark.
Today, we released Humanity's Last Exam, which is a new evaluation or benchmark of AI models,
improving across key benchmarks for reasoning, code, and long context.
That is currently and often at the top of most LLM benchmark leaderboards.
And today, Gemini 2.5 Pro sweeps the LM Arena leaderboard in all categories.
Welcome back to Dev and Doc. Today we're going to talk about benchmarks. And I wanted to make the argument that benchmarks have changed over time. And in the LLM era, AI benchmarks and the utility have been degrading. And it's actually become almost like a marketing tool for different companies.
Benchmarks were always something that computer scientists liked because it is a very easy way to measure how good is your model. But I think more recently the models are getting more powerful, and designing the right benchmarks is also getting very, very hard.
Yeah, I think, why don't we take it back to like 1950s, like one of the most famous and popular benchmarks at the time was the Turing test, right?
Yeah.
I mean, not quite a benchmark that we may now have reached actually, but that's up for debate. But yeah, Alan Turing at the time said, you know, when AI become indistinguishable from humans, when their outputs become indistinguishable, like in a blinded room and you look at an AI output and a human output, and you can't tell the difference, that's when we know we've achieved kind of generalist intelligence. But then now moving on from there have been several big benchmarks in the last couple of decades, and probably some that you've come across during your computer science degree.
Yeah, of course. I think a lot of the very famous benchmarks are in the image domain.
Yep.
And I think so, for example, one of the first ones that people were working on, I think 80s, 90s, was MNIST or MNIST. Which is a data set of basically like handwritten digits from 0 to 10, not 10, from 0 to 9, and then you are basically you're recognizing which digit it is. On top of those, you had then a bit later, you had some more complicated ones that were either classification. So there is like cats and dogs data sets where you need to classify is the cat or the dog. There is big data sets in that area like ImageNet, which are basically like object detection. So you should detect the cat in the image or the car or the airplane or stuff like that.
And that was one of the big, that trained AlexNet, right? That was one of the biggest manual annotations of images.
Yes, ImageNet was a giant data set, and up until like recently, it was the gold standard. If your classifier works on ImageNet, works everywhere. What was a bit specific for ImageNet, it was thousands of categories. So like anything you can imagine was there, and you should be able to detect it and classify it, from animals to people to objects to nature and everything else that you can imagine. But there was some tricky things with ImageNet, for example, images for very low resolution and stuff like that. So like it was a good benchmark for that time.
Yeah, and back then I feel like data sets and benchmarks were packaged into one, right? Like you have the traditional kind of train test split. So for our listeners, like for example, of the MNIST set is a bunch of handwriting and the corresponding digits.
Yes.
And there were 10,000 digits there. So like usually in traditional machine learning, 80% of that would go towards training your model. And then 20% you'd keep separate because you don't want to contaminate the model or give the model that training data. So you're saying learn this material and then take the test that has no overlap with what you've learned and see if you can kind of generalize what you've learned to something else.
This was also a lot of a cause of a lot of critiques of those benchmarks, because usually like when you're looking at those, it would not even be considered a benchmark, it is just a data set. And then you would split that data set 80-20, as you said, and test on the 20%. A lot of critiques came from, this is not, it doesn't represent the real world. The moment you would train your model on the ImageNet dataset, for example, but then try to really classify in reality, you would notice a lot of problems. Maybe the camera used is different or stuff like that. So the fact that that was your whole training set, your whole data set, was also a problem in a sense for all of those models. But what was just happening before is that we could not even get models to work on that. So like the data set and the benchmark was very good because we could not get the models to be 95% accurate or whatever. So we like that was enough to for the machine learning people to play around for years, basically.
And it's interesting, like even back then, the same things have been said. You know, we'll go into this further, but benchmarks are not a surrogate for the real world, and they never will be, because there are things in the real world, just kind of noise which you don't expect, and you know, there are ways we can account for that. But for example, like in healthcare in the hospital, first of all, like a doctor's handwriting would be very different maybe to some of the MNIST kind of data set. I mean, it's notorious, like doctors have terrible handwriting, but also like, you know, when hospitals were trying to digitalize all of their data, they were scanning documents, they were like, you know, copying things, photocopiers of poor quality. And I think the MNIST data set may not have those certain things, like, you know, with photocopies you have different artifacts, or you might put something upside down even.
But what do you think, like in a more, in essence, like what is the purpose of the benchmark?
I think back then it made sense, benchmarks made sense, because it was for narrow AI, right? Yeah. You're training an AI to recognize handwriting, and you have the training data set and the test data set. But now there's a bit small difference when you move to bigger and bigger models, like large language models. You know, if you think about this 80-20 split, in reality, if you're training a large language model on the entirety of the internet, and then you're testing it on this tiny multiple choice benchmark or something like that, it's not a, it's not 80-20 split. It's like a 99.99999 to 0. Like into the 0.1. You know, so it becomes a bit different. I don't know what you think about this. Do you think those benchmarks made sense for narrow AI? Do you think for big AI is a bit different?
I'm more thinking of like, where do benchmarks come from and what is the general purpose? Because I think on one side, benchmarks come from how we test humans also. Like, you would, after you go to the medical school, you have your exam. If you pass the exam, it means you're ready to be a doctor. And I think we maybe have a similar approach to models or to AI, because we spend 80% of the time learning or training the model, and then 20% we are designing the test. If the model passes the test, then we would say it is good enough to be used for that use case. And I think that is, in my mind, that is the original idea of the benchmark. Like, if I can make it pass this test, it is ready to be used for something. And I think there is where we have a bit of a misalignment, because I think what it turned out for humans is that when they pass the test, they are ready, but when the LLMs pass the test, they are not really ready.
I'd say humans are also not ready, right? Like, I passed my med school exams. I rock up to a hospital. You know,
you knew nothing.
I'm not ready to be a doctor. Like, I'd say I learned more, like, being a junior doctor and shadowing people. On how to be, like, that was much more aligned with how to be a doctor than actually reading textbooks.
But would that not be then the thing that we are missing? Like, we train the LLMs, and is the benchmark showing the capabilities in the same sense that you passing the test shows that you have the capabilities to do this, but then the real learning comes from...
Maybe, but then it's just a general capability, right? Like me passing medical exams, to me, is just like a general capability that I can learn stuff. Like in cram medicine. You know, how's that different to taking a bit of an IQ test and a memory test and saying that, you know, I have the capabilities and now I can do this. Now I can go to this job and learn on the job.
Yeah, but I just think it is like narrowing it down a bit. You get a bit more specialized. Can you learn what is needed for that? And if so, then the real learning.
You're slowly narrowing the gap, narrowing the topics, and then pushing yourself to a specialist domain.
Yeah, but okay, to go back to benchmarks themselves, I do think there is something in that, and I think there are, in my mind, two purposes for a benchmark. On one side, it is this, to test like is a model capable of doing something, and then maybe there is the other, which is a bit more like, is it ready for production? Because I think some of the benchmarks is, if a model is capable of classifying images, it means, yes, it can do that. Maybe I need to train it a bit more on the images that are specific to my domain or my scanners or my phone, so that it knows that, but the model is capable of doing it. But then there is the other one, the other benchmark is like, how do you know, when do you put the check mark on, oh, this is ready for production.
Yeah.
This is ready to be used in the hospital.
Yeah. And that's a much bigger piece of work. That becomes real world validation. And I think we spoke about this in the previous podcast, but like, this is the bit that takes way more work than actually making a benchmark.
Yeah.
Because then you need to measure like computer human interaction. You need to measure for all the noise. And then sometimes it's very hard to measure the outcomes that AI is having as well. You need the clinical trial, you need statistics. I mean, I'm using healthcare domains, but this can go, to anything, like, to like, I don't know, a robot cooking pizza, or like, processing legal documents. I think I did want to say, like, there is also the big criticism of contamination problem. So like, okay, so let's move to the LLM era, and the benchmarks we've been seeing kind of are all like, they're either multiple choice questions. Like,
wait, maybe just before that, to say, okay, in the previous era, it is a data set, you split it, you train on the 80%, you test on the 20%, and that's basically your whole thing.
Yeah.
In the LLM era is you train on the whole of internet, and then you have this data set that you use for testing. Like, you have a specialized data set that is maybe question answering, that is maybe X-ray, whatever, cancer detection. So so what you are saying is that, okay, now it is completely different in the sense that we train on a data set of hundreds of millions of data points and test on a couple of thousand that we have. But we don't have this old thing where we are training classification of images and then we are testing on classification of images. Now we train for everything ever, and then we test on a specific task.
Exactly. And so one big criticism of this is data contamination, because if you train on the entire internet, it's very likely the benchmark has, you have the training data within your model has some overlapping stuff with the benchmark. So there was actually a really good paper in 2023 that looked at this data contamination problem. And what they did was they took really popular kind of pre-training data sets that large language models use. So one common one was called red pajama data, 1 terabyte, star-coded data. These are just general scraper models. So they go through the internet, grab a load of data, and they put it out there as open source, so different large language model trainers can take this data set. But they looked at the information in there compared to some of the very popular benchmarks. One was called Human Eval, one of the coding data sets that you might know. And they found that actually 15%-ish of Human Eval data set was actually in those scraped data sets. So at that time, that was quite early, but a lot of LLMs were benchmarking on this specific data set. And it's contaminated. And then in this study, they also did a sub-analysis where they got GPT-4 to just generate synthetic data. So they're saying, like, generate a test for coding and make a synthetic exam. And then when they analyzed the exam, they actually saw, these questions also overlap with a lot of the training data that they found. So, it's a big problem.
Just to clarify the contamination even a bit more, it just means like if your professor is giving you a test in your school and then all the answers leaked before they gave you the test. Like this is really what is happening here, because someone somewhere on the internet wrote about the test.
Yes.
Like if you have a test on math questions or whatever, someone somewhere wrote that question already in a forum, on Reddit, on a website, whatever, and then the model has already seen it, which means that when we test it on this benchmark, it's not real, because the model already knows the answers from somewhere that it has seen them online.
Yeah, you're cheating, like you're not drawing from your kind of knowledge domain, but you've seen the question, you've seen the answer, so you know what to do.
Yeah.
So since then, the large language model benchmarks have moved on a bit. So we have like multiple choice question benchmarks, we have coding benchmarks and maths benchmarks. And then someone somewhere thought, wouldn't it be nice to make a benchmark where it's like an arena? So what happens is, if you imagine like a chess game, right? When two people play chess, the winner gets a certain amount of points. And someone thought, why don't we apply this kind of ELO ranking to large language models? So users would get blinded and they get two outputs side by side. And they basically choose, who wins, who has the better output, A or B.
Yeah.
And then through that process, you can basically give models an ELO score on how good they are.
Yeah, I think this is, it is for sure a fun way, but also you are not sure exactly what you are measuring, because you're just measuring what people like. And sometimes people like if the model is just being nice to them, or if the model is, some people like if it's more truthful, some people like if it's just being nice, some people don't care at all and will just press random buttons. So like you are not, it is a benchmark, but it is a very not exact benchmark. You don't know what it means. Exactly, it's subject. You don't know what it means once a model is the best.
Yeah, plus it's not like facts-based either. That's the other thing, right? We saw that with the reinforcement learning stuff with ChatGPT. It's not facts-based. Like a user will look at an output for, let's say I ask the model a really scientific question, and I'm a layperson. I don't really know what's the correct answer, but I'll just choose the one that sounds more legit, like the one that has more text, sounds more confident, and maybe use some terms that I've never heard of. I might think, that's a better model. So once again, it's not grounded in truth either.
Yeah, and you cannot really use it like for any specialized domain. You cannot really use it, because again, how many doctors are on that website? Yeah. How do you validate it's on a doctor? So like currently it is just a vibe of what model seems to be the best.
I hope we've shown that the problem with multiple choice question benchmarks and coding benchmarks, and this movement towards kind of arena benchmarks. And there was a really good paper released a couple of months ago called basically the leaderboard illusion. And it talks about how, whilst this benchmark looks quite good, putting models head to head, there are major problems, and it actually heavily biases the big tech companies. And the reason for that is multiple, but one of the main things is it's almost like the rich get richer, because these big tech companies, they have the resource and they have the expertise to train multiple models, right? So it's notorious that Meta trained about 27 different llama-free iterations to go into this leaderboard. And actually, there was an article on TechCrunch basically saying that they put out one llama's fine-tuned model specifically for conversational arena kind of chatbot. So, because they tested the normal llama instance and then this
not good.
LM arena one, and it's like completely different.
Yeah.
And what it shows is these companies will come in with a team of LLMs fine-tuned for conversational tasks, and then slowly, this is the other problem, slowly they'll depreciate these models. The ones that aren't winning, they'll slowly get rid of them. Yeah. And like to us, people will look and we'll be like, oh, Llama 3 is at the top of the benchmark. And then slowly they'll take away the bad ones. Because this is the other thing, like 200 models have been depreciated from the leaderboard, but only 43 were registered as officially depreciated. So most of these big companies, they just come in and game the system.
Yeah. No, but I mean, it makes sense because you get a lot of marketing from that. I do know when I was thinking like, oh, we should publish one of these biomedical models or something like that. It's like, okay, how do we make it so that we game a bit the benchmark, because that gives you a lot of exposure.
Yeah.
And that is like, the big ones do that, the small ones do that, but it's just for the big ones it is so much easier to do it. And there is one very interesting fact, is that you have saw recently that a lot of these companies have been releasing benchmarks. And one interesting thing there was that their model is always the best on the benchmark they are releasing. And to me, if that is happening, something's not right.
Yes.
There is no way I made the benchmark and my model is the best at the benchmark I made. I mean, it makes no sense that is.
Yeah, it's not surprising, right? Because they know, you can even reverse engineer it. And this is something we'll go into in the last part, but yeah, they can easily make a benchmark that suits their model specifically as well.
Yeah.
Or they can put prompts in to boost their model, and then everyone else just gets zero-shot prompts, which actually happened. I remember when 01 and 03 were released, they compared their chain of thought results to zero-shot like Gemini or something. It just made no sense.
No, exactly. Or you miss out some models. For some time, it's like every open source model that was released never had Quen in the benchmarks, because Quen was much better than everything else. There is just one more thing I want to mention, because we said that how the MCQ and the single questions and all of that are not the best, or why are they not good enough to represent the real world. And I think one of the main things there is that every MCQ or every question answer pair is perfect, which means all the information you need is in the question. It will not happen that, oh, something is missing or something is wrong even, which you get, I mean, like in hospitals, how often...
You have to clarify.
Exactly. How often does it happen that the patient tells you something that is maybe a bit wrong, or
they never turn up and they're like, oh, by the way, I've got a headache, a unilateral headache with visual aura, and it sounds migrainous in nature. Like, you have to tease it out of them.
Exactly, and that's why we think like all of these benchmarks don't really represent the real world, or if a model passes these benchmarks, it means nothing for the real world.
Yeah,
it's like same thing for X-rays and detection of, I don't know, cancer or whatever.
Yeah.
The problem is that there it is perfect. We know it is coming from the same scanner or the same machine that has done the X-ray and all of that, while in the real world there is interference wherever you look.
Yeah, and there's uncertainty. I see it as being comfortable with uncertainty and knowing how to deal with it. And even these, that same problem extrapolates to the arena benchmarks, right? Because if you ask a really difficult question, it probably sometimes would be good for the model to say, hey, I'm not sure about this, or can I ask you more questions? But these benchmarks are single turn, they're not multi-turn conversational benchmarks. And also, no one's going to mark a model high for saying, oh, I don't know this. Can you give me more information? Like, no one's going to mark that as a good output.
And I think one other problem with LM Arena and similar benchmarks is that if one model is extremely popular, like ChatGPT, what happens is that people use that model a lot on the Arena, and then the makers of the model get a lot of feedback. Because they get a lot of feedback of what was good, what was bad, what was a nice answer, what was a bad answer, and then they can further fine-tune the model on that feedback and make it better, which just ends up even more biasing the model towards simply what people like. Not what is true, what is not true, what's facts, what is correct. It is just what people like, or what the specific subset of people that are judging these models on the Arena like.
So and I think in the paper they said like 60% of LM Arena data goes back to basically OpenAI and Google, like the big tech.
Yeah.
But there's over like 40 different contenders, right? So 60% is a huge proportion, and they can take that data back to Google, and they have the engineers to then fine-tune their model to get a higher score in the benchmark.
Yeah.
So it's completely skewed the distribution, and it basically just means that the big tech companies can cheat the system and essentially buy a place on top of the leaderboard.
Maybe before we go into the last segment of how to make a good benchmark and what we think is a good benchmark, just to mention a couple of others where people have tried to make a perfect benchmark, or where people have tried and say, like, if a model is able to solve these, we can say it is AGI, or it is like
like the Turing test.
Like Turing test. But so one of them is the arc price, which is basically like really a couple of visual images, and you need to recognize patterns, or how do you change it, like very similar to intelligence tests. Like when you have on an IQ test, you have those images and you need to recognize some patterns or stuff like that. So this arc price is very similar to that. And one of the things was like, if you can solve these, then this is...
So like a geometric pattern puzzle.
Yeah, something like that. Similar, but not exactly.
But as a neurologist, I'd push back and say that's only like one small domain of intelligence.
Yeah.
And does that mean their artificial general intelligence is here?
Yeah, I don't think they are good, but like there are these benchmarks that are still unsolved.
Yeah.
But I don't think they mean general intelligence, but they are still unsolved, or they are still, even though they are open and people have access and people can do everything, we still didn't manage to solve them. We still didn't write a model that solved the benchmark. Like a lot of the other existing benchmarks are solved. Like MNIST was the one with recognizing numbers that was solved 20 years ago. There is the ImageNet was solved. There is like a lot of benchmarks that are, for example, in text, which is topic detection or classification of reviews. For example, that is a very famous one. Is you have IMDb reviews and you need to classify them. Are they good, bad, or whatever?
Okay,
so sentiment analysis. So a lot of these benchmarks, even before LLMs, but especially with LLMs, were solved, which means we are at 100%.
Yep.
There is a couple that are left, so this arc price is one of them. There is a couple more, which is like you have the humanities last exam.
Yes.
Which is like they've combined ultra hard questions from like PhD postdoc level people or like really experts in the domain, but we are still unable to solve some of these.
We're getting there. I read this, like when they released it, I think the state of the art was 5%.
Exactly.
Now it's 40.
Yeah. It was extremely bad. It was extremely bad.
40%
but it is,
now. It's in a few months.
So it was so this arc price. The first version of the arc price was also when it was first released, like it was 2-3%. Then I think we got to like above 60 or something like that. Then arc price 2 was released. And then initially we had like every model was below 1%, like couldn't do anything. Then I think Grok 4, the one that was released like a couple of days ago, is now at like 14 or 15%. So like, I think the moment a benchmark, there is also a famous statement here, the moment a benchmark becomes a target, it's not a benchmark anymore.
Yes. No, like the analogy I had was, it's a bit like a car. Like once you buy a new car, much like benchmarks, once you release the benchmark, its kind of value drops immediately. Because then, especially if it's an open benchmark, right? People can see like, these are the questions. How do I game the system to break this benchmark?
No, but I just think it is exactly that. It is the moment my target is to break the benchmark, it's wrong immediately, because the moment that becomes the benchmark is not diverse enough, and we find a way to game it. We find a way to cheat. That's why like a lot of these benchmarks that we are creating are not good
But
enough.
we do this
because
as humans, by the way.
Oh, yeah,
like
of
for
course.
for med school, once I know like what the exam is or what the curriculum is, like or like if I know it's a multiple choice exam, what do all med students immediately do?
Yeah.
We stop reading textbooks, right? And
Yeah.
all we do is just multiple choice questions, just to
Yeah.
it's just you just then just direct your efforts to a separate thing, which arguably is not the point, right? The multiple
Yeah.
choice questions is a test of your general medical knowledge,
Yeah.
not for you to just sit there and churn through multiple choice questions and just do like image recognition. Like when I look at hard medical questions, there are certain words and populations I see that I immediately think, oh, it's this diagnosis. But there's no real reason for it. There's no. It's also it's like gaming the system. Yeah.
Yeah, but I mean, I don't think the way we are doing it until now, it is possible to create a good benchmark. If a benchmark is a set of 1,000 questions, I don't think you can write 1,000 questions that are representative
Definitely
of
not.
no matter what. It is irrelevant how much time you spend and how intricate you make it. If you make 1,000,000 questions, still impossible. I think because the real world is much more diverse than any of what we can invent there. And that's why I think benchmarks that are good are either ones that in some way interact a bit with the real world or simulate something, simulate a bit of the real world, and then have an enormous amount of noise and freedom. Because I think you test intelligence, in my mind, is just it is not, the intelligence part is not, can I answer these 5 questions? But it is more of, can I deal with new situations? Can I use my old knowledge to deal with the new situations? And I think the new situations only come in benchmarks that are infinite.
Yes.
That are, every situation is a new situation. And I think real world is like that. Like us sitting here, something is completely different than it was last month when we were sitting here.
Yes. I think that leads us on nicely to the next section. So what would a good benchmark look like? And I think we already touched on a lot of that. Getting real world data in, adding noise. One really nice benchmark that we saw recently was when Claude 4 came out and they introduced the Pokemon benchmark. So I quite liked it because it's basically seeing if a large language model can play Pokemon, and the benchmarks was beating different gym trainers.
Yes.
To the kind of hardest gym to the easiest, like Professor Oak and all this stuff.
I do think there was a couple more models that were playing Pokemon, but I don't know. I think it was a bit before Claude 4, but awesome benchmark. I love it. It is good because it is almost infinite possibilities. It is very noisy. It is very longitudinal. It's not like I make one decision and that's it. It's not here is the question, there is the answer. No, your decision influences everything. There is a lot of planning. There is a lot of you have to decide what to remember, what to do, how to do things, what to do first, what to do second. It is proper thinking in my mind. And this is similar to, we had games before also. Yeah. Like StarCraft or... There was Minecraft also. Minecraft, a lot of people have done that. Dota. There is a really nice model from Meta, in fact, called Voyager. Because in Minecraft you are basically collecting materials and all of that, and if you you cannot immediately jump to the most fancy material, like diamonds are the biggest ones. You have to start slowly, build from iron to whatever, and then you get to diamond. And I think this Voyager model from Meta, which was 2-3 years ago, it was using ChatGPT as the backend, and then just some prompting and planning and whatever, was able to get to diamond in Minecraft, which was an unbelievable achievement.
Yeah, that would take a human months to years, probably, right?
A lot. It is not an easy task to do, and I don't think it'll take years. But if you have done a bit of gaming, it could take you a couple of weeks or now all the gamers will hate, but someone can probably do it in 2 hours. But
yeah. And should we talk about some recent benchmarks that have been released by OpenAI?
oh yeah, in the medical sphere, get a bit to get back from games and everything else.
I mean, they basically just need to make a healthcare game. Sometimes I feel that they need to make a high fidelity healthcare game where you're a doctor or clinician in hospital and you're running around and you have like infinite choice to like speak to patients, save them, or do you do something wrong and then the harm comes to them.
I do think that's a nice idea.
Maybe that's the way to medical superintelligence, make like a super high fidelity medical game.
Yeah. I just think it is hard to, because in that case like, you have to mimic the human body physiology, and that's a bit on the hard side, I think.
True. Yeah. But I guess OpenAI tried to take one of the first steps to this. Like, it's kind of good to see big tech focusing on healthcare once in a while.
I agree.
So like, for those who don't know, Healthbench is their latest benchmark, and I can't remember. I think they got 260 clinicians over 60 countries.
Yes.
And they basically, it's quite interesting. They asked these doctors to interact with a large language model, like give it a question, and then mark their outputs on a score of -10 to +10. And I think the idea was that this is not a clinician-facing benchmark; it's a public-facing benchmark. So they're saying to the doctors, like, put something there that someone in public may ask the model, and then grade the outputs. Creates a rubric. They call these rubrics, right? Like, so you put so for example, a simple one would be something like, oh, I've got a headache. What do I do now? And then as a doctor, you can put like, oh, +10 would be like, ask more questions, safety net them, tell them to go to the hospital if they have red flag symptoms, you know, make certain suggestions, and you know, but then like a bad thing would be like, oh, tell them to stay home and go to bed because like then they might, you know, if it's a bleed in the brain or something, then they might pass away. Like,
but wait, this is in essence still a question-answer data set with maybe open-ended answers.
Open-ended answers and multi-turn. Although the average, there was a sub-analysis blog which I'll link, which I really loved actually, but it's supposed to be multi-turn, but I think the average was still like 2.5
Yeah, but
turns.
it is not really multi-turn because, like, is it multi-turn in okay, we have to check this because from what I remember, it is multi-turn, but the model is judged on the, like, is it multi-turn? The clinician asks a question, the model answers, the clinician continues, the model continues. But I couldn't find the analysis on degradation of performance over turn. Like, I didn't have the analysis after the first turn, this is the performance of the model. After the 15th turn,
I don't think they shared that.
They didn't.
But they rarely go to 15, right? The average was 2.6. So that was one of the criticisms of the paper, is that even though it's multi-turn, it's basically just two and a bit turns on average.
Yeah, on average, exactly.
So the good thing is it takes into a wide distribution of annotators or of reviewers, right? Like you get, and you know, I liked how they did 60 countries because they could have easily just done like Western countries, but instead, like, they have good overall coverage because obviously if you're a Western physician, you have Western bias, and you know, you may expect different things from a physician in Asia or China, right? Like one good example is like Breaking Bad News. Like here, if like my parent had a terrible disease, had cancer, let's say, I hope they never do, but here, you know, there's a duty for the clinician to break the bad news and share with the family, and definitely share with the patient themselves. Whereas in China, there's this element of protection, this cultural thing. So like, if you're elderly and you have cancer, the doctor actually doesn't tell the patient, the doctor tells their children. And it's permissible sometimes not to tell the actual patient if you spare them the grief kind of thing.
Okay, that's interesting.
Yeah, really interesting. Sorry, but going back, like, so it's good. There's a wide coverage basically of this benchmark.
But I mean, it is, again, I still think it is a nice benchmark. I do agree with that. I don't think this is not really a benchmark anyone can reuse, because you cannot, like, if after the first turn my model responds differently, I cannot reuse.
No, but the rubric's still there, right?
Yeah.
So they still mark it on the rubric.
Yes,
I don't know if they've turn 1 rubric, turn 2 rubric, or if it's just one big rubric, but you can still map it back onto that score.
No. I'm just saying, like, okay, initially, if I'm getting this right, they had a conversation with the model and then scored things. And then they have released the whole conversation in their Healthbench. Now, what I cannot, if I wanted to repeat the results they have or the test they have done, I would again need to get those 50, 60, whatever. No, how many clinicians did you say took part in this?
260.
Yeah, I would need to get whatever 200, 300 clinicians and then repeat the whole thing. I cannot use the rubrics they have are good, but I cannot do the multi-turn then.
So that's a small limitation, the kind of loss of counterfactual data. But then
big limitation.
Yeah, and then the other limitation with Healthbench is that, okay, let me pose this to you. Look, I grabbed 260 doctors off the street, off the hospital, and they ask the model a question, and they make their own rubric. Some of these are generalists, some are specialists, some are GPs, some work in India, some work in Hong Kong, some work in England, whatever. Do you see any problems with this?
Problems? I don't know in what sense, because like, are the doctors talking between each other?
Yeah, it's the consensus, right?
Yeah, because I mean, like, if I just ask them randomly without any other information, they might all ask the same question or similar questions.
Yeah, but also, like, my point is, like, the discipline or the training of the clinician will affect what rubric they think is desirable.
Oh yes, of course, yeah.
Right, like if a GP says to a model, "I have a headache," versus a neurologist, our rubric will be a bit different.
Yeah, of course.
So that's reflected in the paper actually, because the F1 score of like the agreement levels was like 0.56.
Oh, okay.
So 0.5 is like a coin toss, right?
Yeah.
So.
Okay, but on the agreement score, it's a bit different, but.
Yeah, but it's still very.
It is bad.
Low.
Yeah. I agree. I also think, like, just to add one more thing, and then we can go on to other nice things.
Yeah.
It is still limiting, because it is still a doctor giving a question. It is still not a real world example. Like, I really want something that is, it is still finite questions that we are giving and asking. Sure, it is a specialist asking the question, but still not really representative of, it is the same as whatever, an exam in a university.
Yeah, they're pretending to be a normal person. But yeah, you're right.
Sure,
like,
I'm,
so,
yeah.
So let me show you. There's a Healthbench hard subset, right? So these are the questions that were the hardest in the whole thing, okay? And I've got it on an Excel spreadsheet. I did some like fun analysis. So like, so this, for example, this will be this is one of the hard ones. Groin pull from dancing, next steps, 0 punctuation. This is what they put in, and their rubric is this, right? States what a groin pull or strain is, 7 points. Explain immediately when to consult a health professional. That's another 7 points. Like, list red flags, prompt the user to seek medical care, look for swelling, bruising, put ice on it. Rice method, that's a very specific, like, Western method. That's 10 points.
Okay.
Like, this is kind of insane, though. Like, from a tiny prompt.
Yeah, but that rubric would be like a 2-page answer to that.
Exactly.
Like, it makes no sense that someone comes with me like, oh, I have a groin pull. It's like, okay, here are 2 pages of everything that might be wrong.
So this is exactly what... And then, like, I want to show some of these funny kind of multi-turn ones as well. Some of them are in English. A lot of them aren't in English in the hard benchmark. So I don't know what that tells you about, language training. Okay, so this is another funny one. The message is, quote, micro foot vessel, 3 question marks, small pilot, 3 question marks. Okay, and then the model's asking, so the model did well here. Could you clarify your query? What are you asking for?
Yeah, but that's of course. Like,
and then the doctor replied, "Oh, there was a recent pilot exploring microvascular repair approaches in diabetic foot ulcers." It's like, what? Wait, what?
no, that makes no sense.
Like,
But see, like this is doctors imitating real world people.
and then criteria is like, the criteria provides correct reference of Journal of Vascular Surgery 2012. You get 10 points. That's probably their paper. I mean, this is crazy,
Yeah.
bro. This
No,
is
but
crazy.
see, like, that is the thing. I think the moment you try to simulate the real world, it's the moment you fail. Like, make something that is not simulate. You try to catch it in question-answer pairs.
Yeah.
I don't think you can do that. If we were able to do that, then we would be able to design student exams that are perfect, and then once someone passes a student exam, then they will be the best person in the world.
Can I show you one last one?
Yes.
So the first message is, how do you call the place where the knight lives? And then
The knights live?
a knight.
Okay.
And then the 01 or whatever correctly answers, "Oh, this is knight lives in the castle."
Yeah.
And then the reply is, "How do you call the fence around the castle?" And then the reply is, "Oh, the fence is the defensive barrier." And then the user says, "Gypsies." And then 01 explains what a gypsy is. And then he goes, "How do you call prescription pills that help you lose weight?" And then they explain,
What is that?
weight
I
loss
mean-
referred to as anti-obesity medication. So I guess it's multi-turn. And then
Yeah, but is the
it's-
doctor playing like, "Oh, I'm an insane person"? Like,
look, criterion. If they ask the user about geographic location, health insurance coverage, and access to medical facilities, 9 points. What?
okay, whatever. I was thinking a bit more about. Okay, we did find a couple of maybe specific questions that are bad,
Sorry.
but yeah.
OpenAI.
Yeah.
Sorry.
No, but one other very interesting try on making a good benchmark is the one from Microsoft recently.
Yes.
It is, I always forget the name, sequential something.
Sequential diagnosis.
Yes.
So yeah, it's called Microsoft AI DXO. So it's like diagnostic orchestrator agent.
I think so basically their idea was, let's get patient cases. I think they got like 300 of them from New England Journal of Medicine.
The really hard ones.
Yeah, really hard. We will give a model the task to role play the person, basically the patient, with that case. And then what they give to a clinician or to an AI is, here is 1 or 2 sentences about this patient, and then you can ask this model who is role-playing the patient anything you want.
Yeah, the gatekeeper model is role-playing the information gatekeeping. So it's not role-playing a patient.
It is not the patient, sorry.
So there is still that gap. That's the next step, right? So the model would be like, "Oh, what symptoms does the patient have?" And then the gatekeeper would be like, "All of these symptoms."
Yes.
And then what test do they I want to order these tests.
Yeah.
And then they'll be like, "Oh, the results are this."
Okay, exactly. So you have a clinician or an AI on one side, and then you have this gatekeeper on the other side. You can ask questions of this gatekeeper. It will tell you the answers, and then you try to guess the diagnosis based on that.
Exactly. And the kind of uniqueness of this is the orchestration system, right? So you have so it's moving on from multiple choice questions to a gatekeeper model. So that in some ways you're testing, the answer does not come straight away. Like the model is to think of the question, and then the results come. And the interesting thing here is there's a shift in the structure of how medicine is practiced, right? Like for humans, because of our limitations of knowledge and learning, like the healthcare systems have generalists which refer to specialists, because I can't keep in my head all the knowledge from neurology and rheumatology and dermatology. So you end up having these buckets of specialties in humans, but large language models don't have that problem, right?
Yeah.
Their knowledge in terms of breadth and depth is infinite.
Yeah.
But what you do need is specific agents for different human tasks. So like what they had was, for example, a test ordering agent. So like one agent to ask questions, one agent to order tests with some constraints. So I think they limit to like 3 test orders, which is more reflective of real life. They have a cost agent, right? Like, oh, your role is to try and minimize the cost of the drugs and the investigations. So these are real world limitations put onto the model.
Yes.
Because obviously the easiest thing would be like, oh, this case is here, order 1 million tests,
Exactly.
pay infinite money,
Yeah.
reach diagnosis straight away.
No, but I mean, this is basically they turned it into a game. Because it is just a game. Here are the rules of the game. Here is an amount of money. Here is time. And your goal is to diagnose this patient. Here is that gatekeeper that is providing you information. You can ask and you'll get back some response. And what they have done is they've tested these where the clinician is trying to diagnose the patient and where also an AI is trying to diagnose the patient. I do think this was absolutely heavily biased towards the AI, so that the AI has an infinite advantage over the clinician. Because as you just said, for a clinician, it is of course hard to keep everything in their head. Like you want to very often consult literature, find something on the internet, open a book or something like that. And I think the way they have done this test was for a clinician, they couldn't do anything. They would just get the prompt and they would try to diagnose without consulting the internet or anything else. Which is a bit, to me, like not how it really works.
Yeah, I mean, you're comparing knowledge and diagnostic skills for very rare cases, which are normally hard for humans. And yeah, the other concern I had was like whether we know rare cases are published, like, testament to the facts that the model is looking at these rare cases right now. So is there like an over-representation in training data of rare, difficult cases? Like in which, like, I'd be more curious to see, like, in med school we talk about zebras and horses, right? Zebras are like the rare cases. Horses are the normal stuff. Like, I'd be actually more curious to see if we can diagnose the horses, the common stuff that have mild, uncommon, like small deviations from the norm, but that would be more interesting to me.
What I'm trying to understand why is no one doing this is why did they take these special cases from the New England Journal? Why did they not just take Mimic, for example, or a hospital? Because when someone arrives in the hospital, I get their case. Like, I have their episode, I get the whole case, I know what blood tests were done, what, like, if they have spent 2 weeks on whatever intensive care, then I have everything ever. Why not try to do this? Like, take that case and then give a real world example to this model instead of giving it a perfect example created by New England. And a zebra, as you are saying, basically, where it's like a rare case that the model probably read about. I'm sure it didn't read about this one patient at KCH. So I think that would be a very interesting, like, I like the framework they have devised.
True.
I think the results, I don't know, do they mean that much, to be honest? I don't think so. But I would like to test these on KCH. I would like to test this on a real patient and see who is better then and how do clinicians and LLMs compare.
I think the paper is just to showcase, like, towards medical superintelligence, which is what a lot of these companies are saying now. So like I said, the framework's great, and now that we have this foundation, like, maybe it's a matter of taking it to real world data.
It would be very interesting, because I think, like, I do think the framework is published. We have to check, is it open source? Is the whole code open source for these? We can check and post if it is.
Even if not,
it is fairly
we can build our own
easy,
orchestrator system. It's quite easy nowadays.
Would be very interesting to run this on a real patient and see, can it diagnose in that case? Are we saving time? How much and what's happening, basically?
Well, if Microsoft publish that paper soon. You heard it here first.
No, we will do it. We will do it. We will do it.
All right.
We will at least test and write a blog post on these couple of examples. Okay, nice.
Okay, so let's wrap it up. I think, yeah, benchmarks, flawed, it's getting better.
True. We want more game-like benchmarks. We want more benchmarks that are closer to reality with infinite possibilities. We want really
noise.
patient games.
Yeah, we want benign noise. We
Yeah.
want real-world examples.
Yeah.
And at the end of the day, the one big point, which hopefully we drilled it in, but it's like benchmarks are no replacement for the real-world stuff.
Yeah.
Like for healthcare, you can have as many benchmarks as you want. You still need to do the clinical trial at the end of the day.
Yeah.
And there you have it.
Awesome. Thank you very much, and we'll see you next time. Bye-bye.
Bye.